Hello students, welcome back. Now let us have a look at the maximum power transfer theorem. So as we discussed the Thevenin theorem that any network can be replaced with a series combination of VTH and RTH, and now we have RL here. If I change the value of RL, the power across RL, that means power delivered to RL, will change, and this is the curve. Upon finding the local minima, we will realize that when RL is equal to RTH, then we get the maximum power. The power is basically I square R. And what is the current? Current in this series combination is VTH total voltage divided by total resistance, that is RTH plus RL. So VTH divided by RTH plus RL, this is current square RL. Now do the differentiation of this with respect to RL, okay, and then we will find the minima is coming at RL equal to RTH. So when I replace RTH equal to RL, then I get the maximum power, that is VTH square by 4TH. So this is the maximum power that we can deliver. Now if I ask you that this is the question and tell me at what value of RL maximum power will be transferred. Basically, I am asking what is the value of RTH. So find the RTH for this network. That is all. If I ask what is the value of maximum power transferred, then we will say, okay, the formula is VTH square by 4 times RTH. Now I want VTH value also. So find VTH also between A and B. So basically maximum power transfer theorem is just another way of saying Thevenin's theorem. You have to still find the same two parameters, VTH and RTH. Now one more theorem that we have is reciprocity theorem. In the reciprocity theorem we say that if I have a circuit where I have linear circuit, I have bilateral, that means two-port network, and I have only one independent source, then the ratio of response means output, excitation means input, that means V out by V in, or I can take output current by input current or output current by input voltage, any output parameter divided by input parameter, this ratio will remain same even if we interchange the source from input terminal to output terminal. So look at this condition, this circuit. There is only one independent source. Output parameter is I, input parameter is Vs. If I interchange these position, that means the combination of Vs and this goes on this side, and I start measuring current on this side, then the ratio of I by Vs remains same. For example, consider this circuit. I have 15 volt this side and this 0.5 ampere is flowing here. As you can see, this 10 ohm, they will be in parallel, so they will make 5 ohm. 5 and 10 will be 15, so total current will be 1 ampere here. Out of 1 ampere, half will go here, half will go here. Now, if I interchange these positions, so what I am doing, I keep this as it is, this one as it is, and this 15 ohm comes here. Now you can see that this, instead of 15 I have taken 45. We will do that later. Let us assume this is 15 only. So if you see again, this 10 and this 10, they are in parallel, so they will make 5 plus 10, 15. That means 1 ampere is coming from here, half is going here, half is going here. So still the value of this I is 0.5. Now if I make this 15 into 45, then by linearity output will also increase by 3 times, so this will become 1.5. so that is why we got the answer 1.5. One more example, if 30 volt is delivering 1 ampere, then 6 volt will deliver 0.2. So this is about the maximum power transfer and reciprocity theorem. Keep learning. Thank you.